So let's just go ahead and start off with your background. Maybe tell us a little bit about yourself.
Yeah, so I was an undergrad at Harvard, graduated 2020 in the COVID era, and I spent a few years full time at Google. So I was in a Google infrastructure group in Google Cloud. And so a lot of my work, I was there for 3 years. A lot of my work was in network infrastructure, so a lot of networking systems, which was actually it worked really well. The team I was working on the engineering side was doing um, packet processors. So anywhere in Google's network where an end host is processing packets, the thing that my team worked on was deployed there. So the nice part about that is then you get to interact with a bunch of different components in Google's system. Maybe you're at the edge and doing some load balancing or firewall work. Maybe it's like the same engine that's used in network virtualization for cloud instances. So it let me touch a lot of parts of the Google system stack. But then the end of my time there, this is around when Google was putting a lot of effort behind their Pathways project, which is their large scale distributed model training stack. And so I spent the last chunk of my time there working on network infra stuff for Pathways. But I wasn't, I loved the folks I was working with. I really enjoyed the stuff I was doing. I just wasn't convinced I wanted to be a networking guy forever. And so that's ultimately what led me to the PhD. So I wanted to go more freely explore and find something I was excited about. But in particular, I'm a Berkeley PhD student, and I feel very fortunate that's the case because really when I was thinking about applying to PhDs, I just wanted to go to Berkeley, maybe Stanford too, for the reason that I liked being an engineer. I liked building things and shipping things, I like getting my hands dirty. Um, and so I really liked that these Berkeley labs have such an emphasis on open source, on taking the research, but then actually shipping it out into the world and measuring its usefulness and its impact that way. So I joined the lab at Berkeley. Like I said, I was trying to figure out what I wanted to do. That was the whole point of joining. So the first year, it was just a lot of exploring. But it's really the best place to do it. So usually how it works in these labs is our faculty will put us in touch with more senior students and have us join some of their ongoing work just to start doing something in the lab. And these Berkeley labs are a great place to do that because my lab, for example, this is when the co-creators of VLLM in the lab and SkyPilot are in the lab and MemGPT now Leda are in the lab. And so there are all these, high visibility, very exciting projects happening. And so in my first year, I took on maybe too many new things as I tried to explore, but mostly focused on uh, model inference, so language model inference systems. And then the second year, I was increasingly interested in systems for post training. The context for this is like in the summer, maybe July, Llama 3 herd of models come out, and there's all this discussion over the way they're doing model distillation and data synthesis pipelines for their training stack. And then September '01 preview comes out from OpenAI. So now everyone's excited about reasoning. People are excited to start, I don't know. This is still pre DeepSeek R1, so not everyone is using RL yet, but a lot of folks are trying to reproduce '01 preview with various post-training strategies. And then I attended the Ray Summit in SF, where I'm watching all of these companies give presentations on their model training stack. And there's like increasing sophistication in the post-training side of things and the way that they are doing these things like distillation and data synthesis and now reinforcement learning. So it seemed like to a systems PhD student, it seemed like, okay, a bunch of people are doing roughly the same thing, but building their bespoke frameworks for being. So maybe there's an opportunity here to, I don't know, try to take a principled approach and address this like emerging interest in post training. So really, for the last maybe year now, a lot of my time has been on post training systems and in particular reinforcement learning. And I'm sure we'll dig into this more, but that's basically led to the work that I've been doing for the last several months of both building systems for reinforcement learning and also trying to train some great models using those systems.
Hmm. Awesome. So starting all the way back when you were in undergrad, maybe tell us a little bit about your experience there. Sort of like what led you to working at Google? What was your experience? How did you first get interested in computer science, systems, infrastructure, things like that?
Yeah, good questions. Um, yeah, I was joining. I was at Harvard. I am from a really small rural town in Kansas. We did not have any computing classes. I had not written code prior to going to college. I go to college, I take an intro computer science class, and it was a lot of fun. And so it was really like that simple. From then on out in undergrad, I knew that I was going to study computer science, and I was just trying to take as many of these exciting classes as I could. And a lot of my interests were really like converging on the more systems topics. So I was taking these, operating systems, distributed systems classes. But it was never, my plan was never to do a PhD and never even to do research. I think maybe what happened is once I got excited about computer science, I looked at the students more senior than myself and was thinking, okay, what are these students doing? And I'll use that as some gauge as what I could or should do next. And a lot of them are really excited about going to big tech and working in big tech. And so I'm like, okay, that's the move. I work really hard, take cool classes, and then I'll go work at Google. And so it was pretty early on that was in the back of my head as the plan. And then I guess I did that, and I had a great time at Google. As I said, I was there for a few years. But at some point, I realized, like, I guess if unless I make another decision, I'm just going to be here forever. And I think that happens to a lot of people who they're a couple years out of undergrad. Up until that point, there's always been a plan. Every like 4 years, something changes, and now you kind of realize, if you just like passively let things happen, you're now doing the thing you might be doing forever. And so I started thinking a lot more seriously about what I wanted to do next, and this was coinciding with uh, not feeling married to being a networks guy forever. And so that's what, as I mentioned previously, ultimately led me to go into the PhD to explore some new things. Yeah, but the road to like computer science into Berkeley was like very unexpected. Just happened to really enjoy these classes in undergrad, and then like happened to get maybe a little bored, maybe a little uninterested in my work, and start thinking a little more seriously about what I wanted to do next. And I like wandered and found myself in the PhD program at Berkeley.
So maybe tell us a little bit more about how you first found the right advisors at Berkeley. I think this is something a lot of PhD students have to deal with. Like, what topic do I want to work on? What
Yeah.
advisors make sense? And then also like to the extent you're able to maybe just like at a high level, like you mentioned some of your work was in infrastructure. Like, what skills do you feel like you developed at Google over those few years that maybe you hadn't at Harvard, and how have some of those skills maybe translated to your PhD?
Yeah. So to the first question about advisors, in some ways I lucked out in that when you join Berkeley, you're given temporary advisor or temporary co-advisors. And one of those temporary advisors was Jan Stoika, who is now still my advisor. And I don't know, I feel like just interpersonally, we hit it off very early, but then also, Jan has such a like track record of working on some really high impact projects and just kind of having an nose for the trends and what's coming next and where to pour into. And so it's something I really have respected and wanted to learn from. And then it was also the year I was joining the Berkeley PhD is the year that Matei Zaharia was moving from Stanford to Berkeley. And so he was in Berkeley. He didn't yet have any Berkeley students. And I think just like in the first week of my PhD, he said, "Hey, I'm interested in like large scale systems and machine learning and all these other words that were really exciting and things that I also wanted to work on." And so um, in my first year, I just spent several months. We ended up working on a project together. I reached out to him, asked, "Hey, I want to work on these things that you said you're excited about. Let's find a project here." Spent some time trying to figure out what that is. Ultimately, worked on a project together, and then that was also nice because that means we had this like opportunity to mutually, I don't know, scope each other out and see whether this was a advisor advisee relationship that we were happy with. And so we got a chance to actually work together. And then ultimately I asked if he would co-advise with Jan, and he said he'd be happy to do so. And so yeah, I feel really lucky because for Jan, it just as soon as I joined, he was already an advisor, and then Matei happened to be joining Berkeley at the same time. So that just worked out. I know it can be different for a lot of other folks who there is like a longer, maybe uncomfortable period of trying to find the right advisor fit. And so unfortunately I don't have good wisdom for those folks because I was quite lucky from the beginning. But then to your second question about, maybe experience working in Google Infra and some things I learned there. So, I mean, like from the specifics of the technical details of what I worked on, it's not like there's a lot that directly transfers from the network infrastructure work I was doing at Google to some of the model training systems I do now. But I think there was value that is sometimes hard to pin down of just getting experience working in a team of other people where you're all jointly responsible for the success of whatever you're building, learning, I don't know, how to organize your time and life in priorities when you now have a lot more ambiguity than you previously did in undergrad. So there's a lot of soft skills that I think were just nice. And I'm really impressed by undergrads who go straight through PhD and seem to be doing really well, because I feel like I just matured a lot in the way that I actually work with others and or organize my own work when I was at Google. But then on the infrastructure side, like I mean, Google Infra is a beautiful thing. Like all of the internal tooling, all of the expertise, and so in many ways I was spoiled there. But on the other hand, it also, of course, there's always messy things everywhere as well. But it did let me see, oh, here are some things you can build if you do things well and build this infrastructure correctly. And so I think it did, researchers get a hard time for like writing PhD quality code, just like this throwaway garbled spaghetti code. And I do think my experience at Google has, uh, I don't know, maybe some people would still say my code is bad, but it like perhaps gave me a higher standard for building the systems that I build in a more principled way that actually makes me excited to use them. And I think this is actually something that is underappreciated, like even among researchers, is like I think every researcher would agree that the easier it is to run some evaluation, the more likely it is you're going to run it, and vice versa. And so I have just found in my own research the like commitment to setting up some quality um, system, but then also the frameworks you use to evaluate that thing early on really amplify and accelerate your own research. And so I think a lot of that was just like coming from seeing, some of the rigor in tooling at Google.
Mhm. Awesome. So maybe we can, start getting into some of your work. So you worked on a lot of really amazing things, ranging from sort of GitHub repositories to papers, so on and so forth. But maybe we can start with SkyRL, which is a repository that you wrote. Maybe tell us a little bit about this and sort of like the motivation, how long the project's been going on for, things like that.
Mhm. Yeah, good question. So we let's see, trying to set a timeline. So when I said that for the past year I've been working primarily in post training. Around that time, there were a few other PhD students in the lab who were similarly interested in post training, but maybe from different angles, maybe from a more methods angle of how to train a reasoning model, whereas others are more from the systems angle. And so it led to this really organic collaboration among a few PhD students in the lab to start working in this space. So early on, we were working on reasoning models. That's Sky T1 that we'll talk about more. And I think in academia, we were relatively early to start applying reinforcement learning to both reasoning, but then to these now like tool use agents. And so through that process of being, I think, very early power users of the open source frameworks that existed at the time to do reinforcement learning, I think we had in many ways pushed a lot of these existing frameworks to their limits, or we've found ways that we thought that they could be improved, or some headaches that we had in using them. And so, having done that for several months, I think some, especially as system PhDs who themselves have strong feelings about the way things should be built, we started having ideas of how we think an RL framework should look in the regime, especially of these like tool use agents, as opposed perhaps to RLHF, where we feel like the requirements of the system have evolved quite a lot between those two time points. And so, um, yeah, we had started like building, I can't even remember now, maybe March or April, we started actually building from scratch SkyRL as a framework for doing reinforcement learning on language models, but in particular with like focusing on the agentic use case where you have the policy model interacting with some rich environment, you calling into some tools to execute in that environment. And so the development was pretty rapid. So we released last week of June. So I guess it's maybe April, May, June, maybe 2 to 3 months of a lot of hard work from the team to get this together. And then since then, it's been another maybe only 2.5 months, and there's continued to be such fast iteration and improvement and progress in the stack. Yeah, and so once we released at the end of June, I think what all of us are excited about is just getting people to use this. I mean, this is something that we built largely for ourselves because we had hit some pain points that we wanted to resolve, but we hoped it was something that was also useful to others, especially other researchers and folks in the open source community. And so once we released, a lot of my time at least pivoted to trying to support these early users and these like core users doing interesting things with SkyRL. And it's also like extremely beneficial to us, both as practitioners and as researchers, because as we work really closely with these other great researchers and practitioners, we start seeing the problems or challenges they hit when they're trying to execute whatever their reinforcement learning workflow is. And so we start seeing some of these challenges, maybe some of which are more fundamental than others. We start seeing these relatively early. And for us, that's either something fun to like build and hack on and improve, or it's a paper opportunity. It's something where we can actually find some fundamental research question at the heart of some of these challenges and work on addressing it. And so yeah, for the last couple of months, I think we've just had a lot of fun continuing to iterate on the stack and see some early users be successful in using it and trying to continue to support them the best we can.
Mhm. Awesome. So, I mean, you guys started with Sky Agent, like this agent layer for training long horizon real world agents. And then you guys added on SkyRL Train, SkyRL Gym. So, what do you sort of see as, some things on the horizon for what you guys sort of want to expand into over time?
Yeah, good question. So I'll say this, I feel that this area is still very new for all of the excitement around reinforcement learning and agents and environments. It's still really early. And in particular, I think it is still quite early, at least in the open source world, still quite early in um, fully understanding the system requirements that this workflow places on the RL stack. And I think we're getting much closer to having the understanding where you'll see a lot of design decisions around these RL frameworks start to converge. And so even though we have these components, we have SkyRL Train, which is largely the training engine. So this is where you're going to have you're going to do your model parameter updates. It's going to serve the inference engines for you to get rollouts. We have the agent layer, which is trying to help users who have these like tool use environments that they want to execute, and we'd like to help them also scale those environments, which is a big challenge for a lot of folks. And then the gym, like you said, this is pretty related to the agent. It's like an entry point for we've standardized the gym around the gymnasium step based interface. And so this is like a really nice entry point, especially for researchers who just they don't want to care about the training stack, they don't want to care about the inference stack. They understand this step-based interface, and they want to implement their like relatively simple environment in the interface. So this is like a really easy, common entry point for a lot of users. And so even among those three components, I still think there's a lot of room for improvement in working with the community to understand what would be most helpful to them, even before thinking beyond that. So a few things I have in mind, like despite all of the complexity of an RL training stack, um, when we are working with users and we're trying to make sure everything can get set up and run easily on whatever their compute environment is, it is often the case that setting up SkyRL, the training stack, is the easiest part, which is surprising. Like getting our like FSDP trainer running on their GPUs and making sure the inference engines are set up. Maybe they're co-locating these, which adds some complexity. But we actually find that to often be quite easy relative to the other challenge of actually scaling their environments. So maybe they're trying to do a software engineering task or a terminal use task where for each trajectory, you'll spin up maybe some Docker container that actually has a GitHub repo that's been cloned and installed into that container. And now the agent is interacting with that repo, trying to resolve some GitHub issue. But then when you think about training, you're now maybe your batch size, I don't know, maybe your batch size is 64. Maybe for each of those 64, your GRPO group size is like 8. Maybe you're running multiple training runs in parallel, maybe running evaluations in parallel. Like you can pretty quickly get up to like thousands of these containers needing to be spun up in parallel. And that often ends up placing like a larger burden on the existing infrastructure that folks have in place than the training stack itself does. And so I think there's a lot of room to improve, especially in the open source community, and something that we would also like to help work on is making it a lot easier for people just to focus on the implementation of their environment and its fidelity and its execution efficiency, and give them more tooling to handle all of this scaling problem for them. So that's another area I'm excited about. Another one is I still think, there's been some papers and frameworks and blog posts on it. I still think in the open source community, like this asynchronous, this off policy reinforcement learning is still really maybe misunderstood or maybe not understood. And that I think, especially for researchers, it makes sense. You're doing research, you're wanting to evaluate a singular research idea, and so you want to ablate everything else away. And so adding some like off policy dynamics into that is feels distracting. It feels like inviting more noise. And so it makes a lot of sense that these folks want to do fully synchronous, fully online reinforcement learning. But I think for those who are like serious about training model, just in terms of like training efficiency and the ability to scale, I think not using off policy, even if just one step off policy training, is leaving a lot on the table. And so another area I'm excited about, and I think several other folks in open source are working on this, is trying to build more like community intuition for what goes well and what doesn't, and how to address it when you're starting to do this asynchronous and off policy training. Like as one example of the benefit, like something we've seen. So we're academics, we get a bunch of random compute. Maybe this cloud gives us some credits, that cloud gives us some credits. And we want to make use of all of this compute that we can. And previously, if you're just doing a large scale training run, not reinforcement learning, just like some SFT training run, it's kind of hard to make use of all of this disparate stranded compute, because you kind of want like one cluster with high bandwidth interconnects for your whole training stack running there. But with reinforcement learning, the opportunity is you're doing generation. You're doing this long form generation with inference engines that are naively data parallel. So I can just throw inference engines, I can throw samplers in across all of this different compute. As soon as you do that, though, your training stack and your generation stack are on separate hardware. So if you only run one at a time, you're leaving the other idle and underutilized. So you kind of you want to run both, but you're running both. Okay, well now you have to accept some off policy behavior. And so I think like the ability to leverage the best hardware for the job and the ability to scale, all of these things I think are hinging on accepting off policy training. And so anyways, yeah, I'm just like, it's another area that I want to keep pushing on to encourage folks to explore more.
Awesome. So moving forward, you've sort of been a large part of NovaSky, and so Sky T1 was sort of part of this origin story. I mean, we've sort of already covered some work with SkyRL, but dating even before SkyRL happened, you had Sky T1. So maybe tell us a little bit about the origin story of like NovaSky, the early days with Sky T1, things like that.
Yeah, Sky T1 is a funny piece of work from our team in that it is like extremely simple and feels quaint looking backwards, but just a matter of good timing and execution ended up giving a lot of visibility to the project through this. So as I mentioned at the end of last calendar year, like myself and a few other PhD students were interested in post-training, interested in reasoning, and starting to explore, and like I said, O1 preview had come out, And so folks are starting to explore how to build reasoning models. So in academia, a lot of folks were exploring like these explicit tree search algorithms, like the Monte Carlo tree search, and um, you know, was it Quen? Yeah, I think it was Quen 32b comes out, and it's like the first strong-ish open thinking model, open reasoning model. And so, okay, so we have O1 preview, which we're trying to reproduce. We have like this Quen model that's like roughly as good as this O1 preview model. And so we started just like poking into this Quen reasoning model, trying to understand, okay, what are like, what's its behavior? Let's read through some of its responses and try to better understand what's going on here to, I don't know, try to reverse engineer how we can train this thing. And so at some point, all we did is we just thought, okay, like we have these long form reasoning traces that we can get out of the Quen model. Like how easy could we just transfer that long form thought process to other models? And so we did like something as simple as ask it a bunch of math questions, take its long form reasoning, use that to create our SFT data set, and fine tune some other model or some smaller model even. And what we found is like the ability to transfer this reasoning capability was extremely efficient, like with very few samples. So I think in the Sky T1 blog post, we said like 17,000 samples, where that's a mixture of some math. We also did some coding, some science, and general knowledge questions. And it's like 17,000 samples. That's all you need to lift like this non-reasoning model to O1 preview performance. And again, super simple. This is just like some prompt distillation, and it got a lot of attention. I think because even though this Quen model was open, I think the intuition in the community wasn't built yet around reasoning and how easy this capability of long form chain of thought, how efficient it could be transferred. Now we've like learned a lot more. Like folks did, okay, I can actually do this in 1,000 samples. I can do it in 100 samples. I can do it in one sample. We've learned, okay, the Quen models, the base models are just really strong. Turns out they had like this long form chain of thought in their data set. So we've like learned many more lessons, but I think this is just one early paper that happened to, or blog post, I guess, that happened to coincide with just a few weeks later, R1, DeepSeek R1 comes out. And so now the world's really excited about reinforcement learning, DeepSeek, reinforcement learning for reasoning. And so I think our work got bundled up with some of the discussion around R1, especially in the discussion of how easy or how efficiently one could train these reasoning models. So of course, someone needed to train the first long form reasoning models, but once you had it, the ease with which, or maybe the low cost with which you could transfer that capability to another model was pretty surprising at the time. So there's a New York Times article, Washington Post, The Information, that are all mostly about DeepSeek R1, but then NovaSky, we get a brief shout out and they say, hey, look, these researchers are also trying to, like, they are showing some results in really cheaply transferring capabilities from one model to another. And so I think, like, for us as a group, that I mean, again, we just started some work. A lot of this happened over like the winter break, because we had got some compute from the Lambda research cluster, and I think the engineers and researchers there were taking some like Christmas holiday, and so there's a bunch of open compute, and so we were all busily running jobs, just trying to make use of this compute, and so really we're just like trying to better understand reasoning. And I think like when there was even as simple of a work as this was, when there was a lot of attention and buzz in the space, I think it got all of us really excited. And when R1 had come out, we had already internally started running pretty extensively some reinforcement learning experiments of our own, trying now to move beyond distillation to actually, but actually trying to encourage this long form chain of thought through reinforcement learning. So yeah, I think we just kind of like, again, a lot of like combination of luck, but then also curiosity and just following that curiosity and trying to understand these new and interesting things that were happening. And it landed us in a spot. We were like relatively early to reasoning and relatively early to reinforcement learning and reinforcement learning for agents. And that's really what I think all of those had the ingredients of leading to SkyRL. because I think we're also relatively early to observing many of the challenges that exist when trying to take framework, RL framework built for RLHF or for an earlier area, and now try to use that same framework for agentic workloads. And so, yeah, I think that planted a seed for a lot of the stuff we're doing with SkyRL now.
Hmm. Awesome. So, sort of moving forward, there were a few papers that you worked on sort of throughout your PhD that were super exciting. You had one titled Melange, Cost Efficient LLM Serving by Exploiting GPU Heterogeneity. So, I don't think we've covered this one yet. Maybe tell us a little bit about this paper and sort of how it impacted the rest of your journey.
Yeah, so this is one of the papers that came as a result of my exploration in the first year. So this was when I was talking to some Sky Pilot folks who were working on the Sky Serve feature, which is like the ability to serve a model across different data parallel inference engines, but these inference engines may be on different regions or different clouds even, or using spot instances, just trying to have minimize the cost but maintain some high availability of your serving workload. And so another aspect of that is like heterogeneous hardware. So not only can we run serving on the only on A100s, but we'll find the cheapest possible A100s across all these clouds and spot instances and on demand. But I started getting interested in how to better utilize heterogeneous hardware. This is largely because, and I assume this is still the case today, is that there are a lot of clusters out there that are or companies that have purchased a lot of GPUs that are now considered older model families. So maybe some people would call A100 this, but we're talking like V100s or L4s or even T4s. Like they're all of this old hardware that was really expensive and you'd like to squeeze as much value out of it as you can. And I think for the most part, the more natural way to do this is with some like large batch offline workload where you don't really need the like quick short latency responses that you need from online serving. And so I think that made a lot of sense, but we also were in a situation where we ourselves had access to these older GPUs, or maybe these GPUs were available in public clouds and they were super cheap, but we couldn't use them for our serving workloads because their like response times were just too slow. And so I was a little curious whether we could do something more about that. And so I was just trying to understand like the different, generation dynamics of these different GPU models. And so basically, I mean, the like core idea of the paper, which again might be more obvious now, but at the time was like it turns out that if you measure the like tokens per dollar for any given GPU, where that means how many tokens did you serve? For now, let's assume that's input plus output tokens, and then you're like dividing by the price of that instance per hour. It turns out that for workloads where you have a short prompt, short response, that the like cheaper GPUs, these like slightly wimpier GPUs, actually have much better tokens per dollar than the big beefier GPUs. And then again, unsurprisingly, like as you have these really long context workloads or long generation workloads, like the throughput of these like H100s is you're not going to beat it, and the prices like the price to performance is excellent. So the tokens per dollar is going to be much higher than these wimpier GPUs. But anyways, like once you know this, if you've profiled all of the GPUs that are available to you, and you understand this curve of how does the like my tokens per dollar change as the workload changes, you can start making like more intelligent either allocation decisions or scheduling decisions, like load balancing decisions. Like maybe if I've observed my workload for some time and I use that historical trend as some predictor for the future, I kind of know, okay, like 20% of my workload are these really small short input, short output things. And then the other 80% are longer conversations, or like some document summarization questions. And so then what I can do is instead of just allocating, okay, I'll just stack A100s or H100s until I can meet this whole workload, realize, okay, actually this 20% of your workload, under some constraint of like some SLO, so like some response time, I can actually get a bunch of L4, L40s, T4s, and I can like save. It's going to be like 20% the cost if I had used H100s instead. And so um, I think a lot of so that was like the main core idea of this paper. I think like where it fits into the broader story of my work is I think it was just like um, having come in, I was first largely working on inference workloads where I was looking at a single inference engine and I'm thinking about how to improve this, like I don't know, time per output token or time to first token for this particular thing. But I think I did find, as related to my work at Google, that a lot of my excitement came more around, I don't know, maybe orchestrating or seeing like some holistic system end to end. So once we built this, I kept feeling like itchy to want to, okay, actually we can make good auto scaling decisions based on this as well. Like we're going to scale up and scale down. And so your workload is going to change over time, how to react to it. And so I wanted a more holistic approach of the system I was building. And so I think that's why when we started working on Sky T1 and SkyRL, is that I was really excited about like building some end-to-end system rather than zooming in on one particular aspect and trying to improve or accelerate that thing, which by the way I think is a completely valid and exciting thing to work on. It's just something I learned about myself and where I get a lot of excitement.
Awesome. And so, sort of moving forward, you've clearly worked across a bunch of different backgrounds, right? So you're an undergrad at Harvard. You sort of took some classes there. You at Google, so you have some time, full-time work experience as well, and then PhD as well. So you have a lot of really different backgrounds. What would sort of be your advice to students, maybe undergrads or masters, or maybe in some PhD students, on maybe how to be a good researcher, primarily for open source contributions, like people that want to build open source projects? Like, what are some things that you've learned in that journey?
Yeah. Yeah, good question. I don't know if I'm qualified to give too much advice, but I can at least share some of my own experiences along the way. Um, like I think um, was clear at Google, but is just always increasingly clear with time is how important the people around you and who you choose to work with and surround yourself with are, how important they are. Um, and just the importance of surrounding yourself with the best people. And like, yes, when I say best, that you should definitely surround yourself with the strongest researchers who are working hard and really passionate about their work. I think that's really important, and a lot of what the ways that I've learned and have developed have come directly from choosing to put myself right next to someone who is so good that they make me a little uncomfortable and a little doubtful about my own skills. But then the like ability to learn from that person is so valuable. But beyond that, like just people that you're excited about working with every day. Like this work on SkyRL. Like we're burning a lot of midnight oil working on this, spending a lot of time. If you're not excited to go like in the trenches and work with these people, it's just going to be really hard to keep up the motivation. And so, yeah, people are super important. I think whether you're in industry, research, whatever it is, I think a lot of when I look at new ideas or projects or directions, like a question near the front of my mind is like, okay, who can I work on with this thing? Um, Maybe more specific to some things specific to open source. Um, like I think the first and foremost is like focus on your users. I'm assuming if you're building an open source, I see a couple different ways. One is like you're a researcher and you just want like people to be able to run and use your work. So maybe you've done some research and you got some results and you want people to be able to easily reproduce those results so that they build on your work and cite your work. And so this is something we did with Sky T1 where we just had a repo where everything you needed to reproduce everything we've done. This is from the data synthesis to the training to the evals is in one repo, and there's scripts to run all of it. So that's great. But I think often those kind of repos are not maintained. You finish the project, you throw it there, it's throwaway code, and you're done. And that's fine. I actually encourage people to do that with their work that they want others to try out. Because if someone wants to cite your paper and they're like thinking about comparing themselves to your paper, I think they're more likely to cite that thing if you are actually making it easy to try out your paper. And it's more than just citations. It's like people will be more willing to build on your work if it's easier to use your work. So that's one area of open source that we started on. I think the other area is probably the one that folks are more interested in, which is like I am trying to build something that I think is useful to others. I want to increase adoption. I want this to be really useful. And I think we're still really early in our journey. That's why I'm not sure I feel qualified to give advice. But something that's already been important is the focus on users and like who is using this, who do you want to be using it. Whoever is using it, you should make sure that they are very successful in doing so, because that's ultimately what's going to drive adoption. So for us, we do a lot of model training internally, and I think the team does a lot of great work there. And so if we can train great models and we say they're trained on SkyRL, we think people will use SkyRL, and that's great. But there's also a lot more people not on our team than there are on our team, and they are also trying to train great models. And so we want them to be building it on SkyRL, and that's really what's going to fuel the adoption. And so focusing on your users, making them successful, whatever that means, like even as simple as, be responsive about, I don't know, bug issues, feature requests. But I think the underlying detail in there that's hard, especially for PhD students, is if you really want this open source thing to be successful, it's going to take a lot of time. Like maybe you want to write a paper, but you're like busy responding to all these, bug issues and feature requests. It's like I think this is not something that you can do halfway, because your users will feel it. Like you'll be slow to iterate, you won't really respond well to changes that need to be made. And so I think it's a big decision to decide to commit to doing this in open source rather than continuing your research and like I don't know, writing papers or contributing like some singular idea to another existing open source stack. So maybe that's my advice in my morning. Maybe the one last thing I would say that I think has been helpful to me is, and I say this primarily because I see this among a lot of people, maybe even more so like researchers, is um, like I think I see people hold themselves back by feeling like they need to prepare for something. And maybe this is people who like go to grad school at all. They say, okay, like people seem to be really excited about these language models, but I don't know much about it. But okay, so I'll go and I'll study for a few years and then I'll be ready and then I can go work on the cool things. I think that's bad advice. I think that's bad advice for a few reasons. One, I think in general, like if you ever want to do something, don't go off and spend a bunch of time preparing for that thing. Just go do it. Um, this isn't true in all fields. Like if you want to be a doctor, please don't go just operate on people. Please go study medicine for a while. But especially in this world, in this like AI frenzy where things are moving really fast, man, the only way you're going to like really get the experience is just by doing it. Like go build things, go join that team, go work on what you're excited about working on. And so I would just encourage people to not hold themselves back, feeling like they need to set aside this big chunk of preparation time. They should just go do it.
Awesome. Our very last question, especially given that your advisors are Jan and Mate, you're also president of CSGE, which is, for people who don't know, the Computer Science Graduate Entrepreneurs Organization at Berkeley. Berkeley has done actually a pretty astoundingly incredible job of really sort of building this entrepreneurial community, in particular at the computer science graduate level, especially compared to a lot of schools on maybe the East Coast, or maybe on sort of like the Northwest. Tell us a little bit about sort of your experience being part of that entrepreneurship community. Why do you think Berkeley's been so effective?
Yeah, good question. Yeah, so as you mentioned, CSGE is this student group at Berkeley for PhD students in EE and CS who are just excited about, these are all researchers, these are all PhD students, but they're also excited about entrepreneurship. And I think a lot of that excitement, there's probably a lot of self-selection here where like people know that Berkeley has had this track record of success and of building really great companies that come out of course, like undergrads are doing a lot of incredible things as well. But like for us, we see our peers and folks who graduated in the labs ahead of us as PhD students really taking their research, focusing on the impact of that research, and then building a great company around it. Um, and so I think that like yeah, this group of students are just folks who are really excited about what they've seen others do and also want to tap into this community. And I think so like why there's been a lot of success and a lot of credit has to go to these faculty who have done it, especially those who have done it on multiple occasions where, they had the experience of starting in building and growing this really successful company. But then also choosing to still come hang out and spend time with all of us PhD students. Like that's a hard thing to do. You've had your success, you made a lot of money. There's a lot of things you could do, and a lot of these faculty are choosing to continue working really closely with these PhD students and continuing to focus on real world impact of their work they're doing. And so I think when you're in a community like that, where you now have a lot of institutional knowledge and experience on turning your research to a company, that like creates some flywheel. Students get excited, and then not only are they excited, but they have the network and the tools to go do that thing. And then once they've done that thing, once they've started their company and had some success, that inspires the next batch of students. And so I do feel like through the hard work of a lot of Berkeley faculty and students and investors over many years, they have slowly gained this momentum that seems to be firing on all cylinders now.
Mm-hmm. Awesome. Without further ado, thank you so much for coming on the podcast. Really appreciate it.
Yeah, thank you.